Hey folks, thanks for stopping by. This week I'm going to get back to the Philco record player Bluetooth conversion project. Stick around, we'll jump in. Okay, I know it looks like a bit of a mess, so let me go over what I plan to do and then I'll go over the pieces that I think I'm going to need to do it. So I've got a Philco record player that has 3 speakers, 2 on the sides and 1 in the front. Has the record player on top, but I've cleaned out everything in the case except for 3 speakers. So what I'd like to do is turn that into a Bluetooth speaker, but not just a Bluetooth speaker. I also want to be able to control it with a remote and also have a volume knob as well. So that's kind of the long and the short of it. Now, devil's in the details. I started with a Dayton 2x30 Bluetooth board. A lot of home, DIY Bluetooth speaker builds start with a Dayton Audio product. They have a bunch of different boards with different wattages, different Bluetooth versions, etc., etc. So it's a great starting point because not only is it a Bluetooth board, but it has headers for controlling a lot of different things. So it has, and if you buy the expansion kit, it comes with a knob for the volume and an LED to indicate that the Bluetooth pairing and a power switch. Yada yada. There's a lot of different inputs that you can add on to the board. So knowing that, I want to be able to control the volume. In order to control the volume, there's a header here that connects to a dual gang potentiometer board that has 6 connections. So this is actually a dual pot. In order to, not actually have an actual volume button, but to have a rotary encoder, or in order to not have a button but have it controlled by the Arduino, what I had to get was a rotary encoder for the actual button. But then to replace the potentiometer, I picked up a couple of digital potentiometers. So it has an input, takes an input from Arduino and outputs differing amounts of resistance. And forgive me if I get the terms wrong. Please feel free to light me up in the comments. I'm just, I'm not an electrical engineer. I just play one on YouTube. So that's how you control the volume. Rotary encoder for the actual knob. There's also an IR sensor. I don't have it here, that I'll use with a remote to control the volume. So either the rotary encoder or the remote control via an IR sensor will control the output to a digital pot that's connected to a header on the board for volume control. Similarly, I've got a relay board. This is a bit overkill for this project, but it's what I had on hand, that will turn the board on and off. So the Arduino will be always on, but the Bluetooth amp will be on or off based on either a switch from the remote or I don't know if I'll actually mount a toggle somewhere. So that is the control for turning it on and off. Now, the board itself, the Dayton Audio board, wants 12 to 24 volts. So what I've got here is a 19 volt, I believe it's 19 volts, laptop power brick. And in order to power the Arduino, I've got a little buck boost converter that will take the 19 volts and send it to the proper voltage for the Arduino Nano that I've got here. And that's what I'm going to be using. Let me go ahead. Well, I've kind of explained it, so it's kind of moved. But let me go ahead and put up a graphic that I did of kind of like the wiring diagram. I'll show you the graphic now and then let's go over it. So at the bottom, we've got power coming in, and one set of power goes directly to the record player. Another set goes to the buck boost converter, which goes over to the Arduino. You'll also notice that I've taken a mono out from the record player and put it into the relay board, because another thing that the Dayton Audio board has is an aux input. So I should be able to switch inputs and activate the record player aux input on the board and switch away from Bluetooth. So that's kind of cool. Moving up here, you see the Arduino and the IR sensor, rotary encoder, and remote, relay boards, digital pots for controlling volume. One of the things, since I have 3 speakers, I've got left and right, and then one in the center. It's not really a center channel, but what I'm going to do is wire up a small little circuit to take both the left and right signal and combine them into a center channel for the speaker in the front. So that is kind of my high level, very rough wiring diagram. So let me. I've got a board here and some jumpers. I'm only going to prototype it today. I just want to kind of make sure that the concept works. I've got a couple of speakers that I'll set here that we can kind of simulate it, but I'm just going to kind of run through mocking it up rather than getting out the perf board and making actual soldered connections. So let me get some of this squared away, and then we'll kind of attack this in a sequential fashion. So we'll be back in a moment.
4 to 6 weeks later.
Okay, it's been a while. I've put everything together generally. On this side is the control circuitry. On this side is the Bluetooth amplifier and connected bits. They're not connected across each other just yet, but that's kind of the last step. I'll do that once I get everything ironed out, actually soldered together onto some boards, so that I can figure out where everything wants to go inside the record player. But I figured I would stop and give you guys a kind of a peek at what's going on. So I've got the Arduino Nano hooked up with an IR sensor, a rotary encoder, a digital pot, and a relay board. I've got it programmed right now so that it modifies the volume. Basically, it's modulating the resistance on the end of this digital pot. And I've got it so that when I turn this, well, you guys can't see it on my screen, but I'm actually seeing the volume go up and down in the serial monitor for the Arduino. And I've also got it so that when I push in on the button, it actually turns the relay on and off. So that'll be the volume control as well as on and off. But at the same time, so I don't have to get up, I've also got it reading from the remote. And again, you guys can't see it, but it's actually printing the codes that were generated by the remote on screen. This side, here, let me turn you guys a little bit. So I've got the Bluetooth board set up, and it actually has an aux-in jack that I'm testing. So, and fingers crossed, this will be the first test to see if it works. So, yeah. Alright, so the record player still turns. And I know I don't know if you guys can hear it, but I don't want to get a copyright strike, so I'm going to stop that real quick. Okay, so that works, but I need to get a line level amplifier, and it's only coming in one channel, so I need to make another circuit that takes left and right signal and or that takes one signal, I guess one signal and puts it on both channels. So I can do that with just a simple bridge. So I'll do that. So that, I know this week's video is kind of short for you. It's been an all-day project for me, and of course, you know, you don't want to sit around watching me poke wires into things. So that's kind of where we're at. In theory, everything works. You know, with it jury rigged the way I've got going. So now I need to start thinking about putting everything actually together, writing the production code that handles the volume. One of the nice things I forgot to mention about this digital pot is that it actually remembers after you power it off what its last value was. So you're not always starting at 0 and having to turn it back up to whatever level you want. So that's kind of cool. What a day. If you made it this far, thanks for sticking with me. Please be sure to subscribe, comment, tell me what you like, tell me what you don't like. And I know this is a variation from my normal stuff, but I thought it was too cool not to share, even if it's not kind of what I do normally. So if you like it, tell me in the comments, or at least give me a thumbs up. See you next time. Take care.